Hello everybody, welcome back to Study is Fun. I am Sasank, and in this video on this session we're talking about subshells, shells and orbitals, not in the same order of course. As we discussed in the last class about importance of chemistry and biology, we started off with atom, right? We started off with how an electron changes its orbit or changes shape of its orbit when given energy or taken energy from it, right? So in an atom, in a real atom, if we take a real atom, what exactly happens is, if you supply or take energy from an electron, it either jumps higher if you provide it with energy, or jumps to the below shell. Now a term called shell came up here. You can also call it orbit or energy level. Now this is exactly what we're going to discuss in today's session, right? So let's start with shells, subshells and orbitals. Now starting off with shells. I'm sorry, oh no, okay. Let's take a shell, okay? What is a shell? Let me first tell you that the most commonly used or the most commonly seen shells are K, L, M, N, O, P, so on, right? So we normally use these four. What we experience in our daily life, it's mostly made out of these, right? So let's take an atom. Let's say that this is the nucleus. Shouldn't have done that. Okay, this is the nucleus, and then you have the first shell, then you have the second, third, fourth, so on. Now this shell right here is the first, this is the second, this is the third, this is the fourth, right? So this is what an atom looks like, right? So these are called shells. Okay, next we have what you call subshells, as you can see here. Subshells. Now there are four types of subshells. There are four types of subshells. Let me just do that. Okay, you have S, you have P, you have D, and then you have F. Right, each one has a different shape. This is circular. This is dumbbell. In today's class, we are going to concentrate only on circular and dumbbell shapes, that is S and P orbital. Not so much about D and F, but they still are important, right? So this dumbbell shape you can see here. You have three dumbbell shapes. Why, I'll explain. What are these three and how are they different from subshells? We will look into that in this video itself. So let's move on to the next, let's say subheading to be sure. You call it orbital. Right, so what is the difference between a subshell and an orbital, right? If you take the 1s, you all might know what 1s is, or even better, let's take a diagram here. Just draw that. Okay, right? So in the first shell you can fill 2 electrons, the next one 8, next one 10. So these are shells, and then you have subshells between them, which you will understand if we clear the concept of orbitals, right? So what are orbitals? Orbitals are those spaces in which electrons are accommodated. A maximum of 2 electrons can be accommodated in each orbital, right? So orbitals have different shapes. Okay, the first one is circular, as we saw. S is circular, and then you have the dumbbell shape for the P, which has 3 types of dumbbells, which we'll see in independent orbitals, right? So you have 1s, which is like this, and then 2s will be a little bigger, and then you have the p subshell, which contains 2px orbital, 2py orbital, and 2pz orbital. Let's start with 2px, right? So it will be in the x direction. If we consider this to be z, and this to be y, and this to be x, right? So it will be something like this, even better. Just right, so something like this. This is z, this is x, this is y. Okay, you have something like this. Not accurate, no. This is the x, right? 2px, this is 2px. Then you have 2py, so that will look something like this. If you can draw it horizontally, something like this. Something like this. 2py, 2py. This is y direction. This is, that's not okay. Now this is z. Okay, this is the graph that we're looking at. If you want to draw 2pz, it will look something like this, right? Now actually they look something like this, not what I drew, but there are some important formulas that you want to remember, and for which we'll try to derive in the next video, right? So let me just give you the formulae. Okay, that is not what I expected, but okay, let's just give you the formula here. Number of electrons in a shell will be 2n square. Now n is the principal quantum number, or what you can call shell number, which is way more easy. Number, let me just rub this out. Okay, now the second one, this is an important formula, and this is intuitive from the first. In a subshell, you have n square number of electrons. So these are important formulas that you might want to remember, and do not get confused between shells, subshells, and orbitals, and try to practice what you've learned in this video. You may or may not, my teaching is not that good, but I hope you enjoyed the video. Thank you very much.